Hello, my name is Zachary Perry, and today I'll be presenting my research project on disk scheduling and the algorithms used in operating systems. So my project will consist of an introduction, an overview of the disk types, and then an overview of the algorithms used within operating systems. So all operating systems use disk scheduling algorithms in order to effectively read and write data to storage devices that are connected to that system. These algorithms allow for fast access times to data already on the device, as well as allow for multiple processes to write data to a disk in unison. Whenever a process needs to read or write data to a disk, the operating system will receive a request from that process and then will determine how the data will be accessed or written. The operating system also needs to consider all other processes that are requesting to read or write data and then determine the priority of each one of those so that it can create a hierarchy of high priority and low priority tasks. These separate processes can be requesting data from the same or even different devices mounted to that operating system, and the operating system will then need to use disk scheduling algorithms in order to handle these requests effectively and allow the OS to run smoothly. The overall goal of these algorithms is to remain fair to all processes while still producing the highest possible throughput of data and producing the minimal traveling of the read and write head of mechanical disk drives. All operating systems use disk scheduling algorithms to effectively store and retrieve data over multiple processes at once. We have established that and that the goal of these algorithms is to reduce the total seek time and total wait time. But what are those? Seek time is the amount of time it takes for the read/write head of a drive to find the sector specified by the process. The total wait time is the amount of time between a process requesting to read or write some data and the disk actually getting the request sent from the IO controller. Some algorithms do not consider one or both of these factors, which makes them not ideal when it comes to handling an OS with multiple processes all requesting the disk. I have referenced a read/write head a couple times, and you might be wondering what that is. Well, there are two different types of drives: hard drives and solid state drives. Hard drives do have this arm, and it is much more important to be considered. So, as an overview, hard drive disks are a type of storage device that consists of one or more magnetically sensitive platters, an actuator arm with this read/write head on it for each platter in the drive, and then a motor to spin both the platter and move the arms. When an operating system requests a hard drive to either read or write data, the IO controller tells the actuator arm where that data is located on the platter, and the arm then needs to travel to that location before the head can gather or write some data to that location. This often leads to a higher seek time, which means that your operating system will feel slower if you do not use an algorithm which tries to reduce the seek time in hard drives. Solid state drives differ in the way that they seek data. They use flash memory, which yields far superior read and write speeds and data access times due to electronically finding and writing the data. They have no moving parts at all, unlike hard drives, and the lack of a rotational magnetic disk allows for more effective and efficient algorithms to be used that don't need to consider where the data is in the flash memory of an SSD. So to go over some of the common algorithms used in operating systems, I'm going to first start first come first serve algorithm is the most simple algorithm used in operating systems. This algorithm executes jobs requested by processes on a first come first serve basis, which often can lead to poor performance when it comes to disk scheduling since there is no consideration of hierarchy or anything of the nature. The only advantage to this algorithm is how easy it is to code and implement, which leads to a very small chance of scheduling errors. However, there are many disadvantages to using this algorithm to perform disk scheduling in an operating system environment. This algorithm is non preemptive, meaning that after the process has been allocated to the CPU, it will never release the CPU until it finishes executing this process. That means the CPU will not move on to any other jobs or do anything else in the operating system besides the first thing it finds while going through the sector. This can lead to extremely high wait times for disk access of things the operating system needs in order to run smoothly. The next algorithm I'm going to be speaking about is the shortest seek time scheduling algorithm. This algorithm is more complex and is also used for disk scheduling in operating systems. It heavily considers where on the disk the data requested is located in order to reduce seek times. This algorithm differs from first come, first serve by not considering when the request came in, but rather how far away the request is from the current one being executed by the CPU and IO controller. The main advantage of the shortest seek time first algorithm is that it increases the throughput of data because the disk spends far less time seeking for the next sector to execute. However, this does come with disadvantages as the complexity of this algorithm leads to the system requiring more resources in order to run. This results in slightly more overhead in finding the next closest location on the disk, and it also can lead to some requests being CPU starved because their data location on the disk may be far from all other requests. In this case, data located further away may have to wait for the CPU to execute before anything else is considered. The next algorithm I will be speaking about is the scan algorithm. The scan algorithm is simpler than the shortest seek time first algorithm and also solves the problem of processes getting CPU starved. When the scan algorithm is implemented, the disk arm starts at one end of the disk and goes through all sectors in ascending order, processing any request from the sector it passes in order. Once the arm gets to the end of the disk, it will go back through all sectors in descending order, processing any requests for sectors which it passes. The main advantage of this algorithm is that it results in very high data throughput and very low variance of response times from the disk. The main disadvantage of this algorithm is that it's the processes that need to access a space behind the last executed request will have to wait for the disk arm to come all the way back before the request is processed. In conclusion, these algorithms all have their advantages and disadvantages. And for that reason, modern operating systems such as Linux, Windows, and Mac OS all use a hybrid approach and don't box themselves into using one algorithm. In real world operating systems, you won't see an algorithm used in a pure form like you did in our textbook or my presentation. Instead, you will see more complex hybrids of different algorithms based on what the designers are trying to accomplish in their use case. Since at the end of the day, all these algorithms have their own advantages in specific situations. These are the references I used for both my research paper and this project, and I will link my paper at the end of this project. Thank you.